this video, we're going to be looking at the composition of functions. So when we're talking about a composition, it means that we're taking one function and plugging it into another. So you'll see our notation over here. We use this little open circle, and we read this as f of g. And it's the same thing as this right here, which essentially means we're taking our g of x function and we're plugging it into f. Okay, now as far as the domain of it, when we find the domain of this composite function, we need to make sure that our x value is in the domain of g here, or whatever function is on the inside. And then we also check the domain of our final equation, which is what this is saying right here, that g of x is in the domain of f. That essentially means look at the new equation that you get and see what the domain restrictions are of that. Okay, so remember just for a second here our function notation. Okay, let me go ahead and add, let's see how I can add a page here, maybe. Let me go down here. Okay, let's say just real quick that I had the function f of x is equal to 3x minus 4. And I said, all right, let's evaluate f of 2. So remember that function notation just means that we're going to take whatever value is inside our parentheses and plug it in for all of our x's. So that would be 3 times 2 minus 4, or 6 minus 4, which is 2. Now, similarly, we can do the same thing with a variable. So I could say find f of the quantity a plus 1. We do the same thing. We take whatever's inside our parentheses and we plug it in for our x. So 3 times the quantity a plus 1 minus 4. Distribute our 3 in and simplify. So when we're looking at the compositions of functions, it's going to be similar to what we have right here, where we're going to be plugging one function, one expression into another. So let me go back to my notes up here. Okay, so to start with, these are our two functions. F of x is equal to 3x minus 4, and g of x is equal to x squared plus 6. Now, just like when we did the combinations in the last video, we're going to start by finding the domain of each of these individual functions so that when we look at our composition, we can find the domain a little easier. All right, now f of x, 3x minus 4, there's no fraction, there's no square root, so by default, our domain is all real numbers. And we can see the same is true of g of x. Okay, so no domain restrictions on those. All right, so the first thing we're going to do is find f of g. Okay, so f of g is saying that we're plugging our g of x function into our f of x function. So we're taking this entire equation, x squared plus 6, and we're substituting it in for our x over here. All right, so what this is going to look like is 3 times, and then we're plugging in the whole g of x, which is x squared plus 6 minus 4. So just like when we did that function notation, we're just plugging in everything that's inside our parentheses for our x value. All right, then we just need to simplify. So distribute the 3 in. So 3x squared plus 18, still minus the 4, and combine our like terms. So 3x squared plus 14. All right, so our new equation is 3x squared plus 14. All right, now for the domain. So remember we have these two conditions up here that we have to satisfy for our domain. So with compositions, you don't have to look at both the original f and g function. You only have to worry about whichever function was on the inside. In this case, it was the g of x that was on the inside, so that's where we're going to start. We need to first find the domain of g, which we said just a second ago was all real numbers. Now, the second thing you look at to satisfy the second criteria right here is your new equation. So in this case, the 3x squared plus 14. And you also look for any domain restrictions that might have come along with this new equation. In this case, 3x squared plus 14 is a quadratic function. There's no denominator, there's no square root. So it also has the domain all real numbers. So domain of the new equation is also all real numbers. All right, so then just like before, we look for what's common to both of those two, but since they're both all real numbers, you put them together and it's still all real numbers. So our final domain here is all reals. All right, let's look at the composition the other direction. So this time we're looking at g of f. So we're going the opposite direction this time. So that means that we're plugging f into g. Okay, plugging f into g. So our whole 3x minus 4 is going in for our x over here. So we'll have 3x minus 4 quantity squared plus 6. All right, and then simplify. So we need to start by squaring this. And remember, when you square a binomial, you have to FOIL. So we're multiplying 3x minus 4 times 3x minus 4. And if we FOILed that out, we would get 9x squared minus 24x plus 16. And we still have the plus 6 right here. All right, and then combine your like terms. So 9x squared minus 24x plus 22. So that is our new equation. And then for our domain, we're going to go through the same process we did for part A. So this time, our inside function is the f of x. So we need the domain of f first, which we said at the beginning was all real numbers. And then we also need the domain of our new equation. So our new equation down here, it's a quadratic again, so no denominator, no square root. So its domain again is all real numbers. So where all reals and all reals overlap is of course also all reals. So that's our answer. All right, let's go ahead and look at another example. Okay, so example 6, we have two different functions. So our f of x is 2 over the quantity x minus 1, and our g of x is 3 over x. So let's again start by just finding each of their individual domains, and then we'll go through and worry about the compositions. So with fractions, we can't have a 0 in the denominator. So for f of x, we'll have x cannot equal 1, and for g of x, we'll have x cannot equal 0. All right, now let's find our compositions. So for part A, we're finding f of g again. F of g, which means we're plugging g into f. Okay, so plugging g into f. So this would look like 2 divided by, and then in place of our x, we're plugging in 3 over x, and still minus 1. All right, so now to simplify this, we want to go ahead and get a common denominator down here. So I'm going to think of my 1 as being 1 over 1, and then multiply it by x over x to get that common denominator. All right, so then this would become 2 divided by, on the bottom here, we would get 3 minus x all over x. Then remember, dividing by a fraction is the same as multiplying by the reciprocal. So we'd have 2 over 1 times x over 3 minus x. Or if we simplify, that becomes 2x over the quantity 3 minus x. All right, so that's going to be our new function, 2x over the quantity 3 minus x. Now for the domain, we need to think about two pieces again. First, the domain of the inside function, which is our g on this one. And for that, we said x cannot equal 0. The domain of g is x cannot equal 0. And then also the domain of the new equation, which if we look at our new equation down here, we can see that with that 3 minus x in the denominator, that means x cannot equal 3. So our composition of functions will have both of those restrictions, that x cannot equal 0 or 3. So our final domain, let's do set notation, is the set of all x values such that x cannot equal 0 or 3. All right, let's look at the composition the other direction as well. So let's find g of f. G of f of x. Hopefully I don't run out of room here. All right, so this direction, we're plugging f into g. So this is g of f of x, okay, plugging f into g. So all of this is going to go in for our x over here. All right, so that's going to be 3 divided by this whole function, 2 over the quantity x minus 1. Again, remember, dividing by a fraction, you just multiply by the reciprocal. So 3 over 1 times x minus 1 over 2. And then simplify. You can distribute that 3 in on the top. So 3x minus 3 all over 2. All right, so that is our function, 3x minus 3 all over 2. Then for the domain, so again, we start by looking at the domain of the inside function, which is our f of x on this one. So domain of f of x, which we said originally was x cannot equal 1. And then also the domain of the new equation, but if we look at our new equation, the denominator is simply a 2. So since there's no variable down there, we know that a 2 can never equal 0, which means there's no domain restrictions that come along with this new equation. So that is simply all reals. All right, so looking at both of those restrictions together, all we have is that x cannot equal 1. So our domain in set notation, set of all x values such that x cannot equal 1. All right, let's look at one more set of compositions. All right, so this time we're looking at f of x is x squared plus 5, g of x is the square root of 3 minus x, and we're looking for the composition f of g. So let's again start with our domains. F of x is a quadratic, no square root, no fraction, so that's domain is just all reals. And with our g of x, we have a square root, so we can't take the square root of a negative number. So we have 3 minus x has to be greater than or equal to 0, which if we solved that out would mean x is less than or equal to 3. All right, so then our f of g of x means we're plugging g into f. So that would be the square root of 3 minus x, quantity squared, plus 5. because we plugged all of G into F. All right, well, when we square a square root, it just cancels out. So that would be 3 minus x plus 5. And then combining our like terms, we would get negative x plus 8. All right, and then for the domain, again, we look at two pieces again. So we start with the domain of the inside function, which is our g on this one. So domain of g, which we said was x is less than or equal to 3. We also have to look at the new equation. And of course, our new equation is just the negative x plus 8, which is a linear function. So no square root, no denominator. So that would just be all reals. So combined together, we just have that x has to be less than or equal to 3. So set up all x such that x is less than or equal to 3. All right, guys, I'm going to end this video here. There will be one more video on our combinations and compositions of functions, looking more specifically at evaluating them numerically for specific x values. So keep watching for more algebra functions.